Hello friends, I am Chandan. So today's topic is today this is our next chapter, that is entropy. So in this chapter we'll understand what is entropy and what is the entropy for reversible process and irreversible process. We'll try to understand this in this chapter. Now first of all, try to understand that what is entropy. So entropy, it is basically the measure of system's thermal energy uh, per unit temperature that is unavailable for doing useful work. So what is entropy? It is the measure of the measure of the measure of system system measure of system thermal energy thermal thermal energy energy per unit temperature per unit temperature that is unavailable that is that is unavailable for doing useful work for for doing useful work. Okay, so what is this? Now the it is the measure of systems thermal energy per unit temperature that is unavailable for doing useful work. Okay, or you can say that a thermodynamic quantity, it is a thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work, often interpreted as the degree of disorder or randomness in the system. Okay, this is the definition of entropy. Okay, so now try to understand what is the entropy for reversible process as well as irreversible process. So there is two case one, that is reversible process, or what is the entropy for reversible cycle, and what is the entropy for irreversible cycle. So let's try to understand the basics of entropy. Okay, now the concept is that first we'll understand what is reversible process. So reversible process means suppose this is an y-axis and this is the x-axis. Okay, suppose in y-axis there is a pressure, maybe temperature, maybe volume, there is a entropy, any kind of properties there, enthalpy is there. Okay, so there is a point, this is point 1, consider this is a state 1. State means any condition of the system is known as state of the system. Okay, so this is state 1, and suppose this state, when you change its temperature, pressure, volume, the state is changing, and this change, suppose this is going to the state 2. Okay, in this path, following this path. So what is reversible process? When a process is said to be a reversible process when it is coming back from final state to initial state without changing any effect on the system and surrounding. So without changing any effect on the surrounding. So this is known as reversible process. Okay, understand this? This is known as reversible process. Now suppose there is state 1 and this is state 2, and one process, that is process A, this is process A, and which is going from state 1 to state 2, and there is a process B which is coming from state 2 to state 1. Okay, this is coming from state 2 to state 1, this is process B. And another process, there is a process C that is coming from state 2 to state 1. Okay. Now in this process, consider here consider 1A 2 B1. This is one cycle because it is going and this is coming. This is anti-clockwise cycle. Okay, it anti-clockwise cycle. Okay, so consider 1A 2 B1. It is one cycle. Okay, this is cycle 1. So consider 1A 2 B1. This is cycle 1, and this is reversible cycle because all the processes are reversible. Consider this A and B and C, all the processes are reversible. Okay, 1A2, this process is reversible. 2B1, this process is also reversible, and 2C1, this process is also reversible. So all are reversible process. Now here what is the given case? So here consider this 1A2 B1, this is cycle 1, this is a reversible cycle, and there is another cycle 1A2 C1, this is cycle 2, this is also reversible cycle. So this is one cycle. So here this is one cycle. Okay, this is one cycle, and another cycle this is. Okay, this is. So 1A 2 C1. So this is another cycle. Okay. So one cycle, that is this cycle, and another cycle, that is this cycle. One cycle, this is one cycle, and this is one cycle. Okay. So focus on the cycle 1. This is cycle 1. So cycle 1, we know from Clausius inequality, we know that cyclic integral from Clausius inequality, we know that cyclic integral of del q sorry cyclic integral of del q by t less than equal to 0, and for reversible process cyclic integral of del q by t that is equal to 0. We know that from Clausius inequality for reversible process. So this is cycle 1, and cyclic integral of for reversible process del q by t that is equal to 0. Okay, so here in cycle 1A2, so this is the cycle 1A2 B1. In this cycle there is two processes there, 1A2 and 2B1. For 1A2 we can say that del q by t for process 1A2 plus del q by t for process 2B1 that is equal to 0 from Clausius inequality. Okay, so this is equation number 1. Okay, now for cycle 2, here cycle 2, in cycle 2 this is cycle 2, here this is our cycle 2. In cycle 2 this is 1A2, this is one process, and 2C1, this is another process, reversible process. So if you apply the Clausius inequality, that is integration of del q by t for cycle 2 that is equal to 0. So from here you can say that del q by t for 1A2, this is process A, plus del q by t for 2C1 process C that is equal to 0. So this is equation number 2. Okay, so there is a two equation. First one, that is equation number 1, this is equation number 1, and this is equation number 2. Now equation 2 minus equation 1, if you subtract this equation 2 minus equation 1, you can get this value, that is del q by t for process C minus del q by t t for process B that is equal to 0. Okay, so from here you can say that is del q by t for process C, that is equal to this, going back to the right hand side. Okay, so del q by t for process B, process B. Okay, so this is equal. Okay, so from here you can say that that is del q by t for reversible process for process cycle C, that is equal to del q by t for reversible process B. Okay, so from here you can say that, so del q by t for reversible process for process cycle, for process C, that is equal to del q by t for reversible process B. Okay, so this is equal here, this is equal. So as this is equal, so you can say that del q by t for reversible process, that is something, that is equal, that means it is something, so that is known as ds. Okay, so basically this is a property, so this is known as entropy. So basically this is a property of a system, so it is denoted as S, capital S. Okay, now so from here you can say that this is basically ds. Okay, this is basically ds. So from here you can come, you can say that ds, that is equal to del q by t for reversible, okay, for process. Okay, so this equation is very important for a process, reversible process. You can say that ds, that is equal to del q by t. Okay, now another, this is case 2 here. In case 2, this is an irreversible cycle or engine. Okay, another same way, this is pressure x, suppose this is y axis and this is x axis. In y axis there may be pressure, volume, temperature is there, or in x axis there is enthalpy or entropy may be there, any property is there. And suppose there is a state 1, this is state 1, this is state 2, and here this is process A, this is a reversible process, and another process, that is 2B1, that is irreversible process, and there is another process 2C1, that is a irreversible process. Okay, so here only the C process, that is irreversible process, another A and B, that is reversible process. So written here, that is 1A2, this is reversible process, and 2B1, it is also reversible process. Now 2C1, this is an irreversible process. Okay, this is an irreversible process. Now when you see that, so 1A2B1, this is one cycle, or you can say that there is another cycle, that is 1A2C1. So here there is a 2 cycle, that is 1A2B1, this is cycle 1, or you can say that this is a reversible cycle, because here these they are this A and B, this is reversible process, so that is why this is an reversible cycle. And here 1A2, this is A1A2, this is reversible cycle, so here 1A2, this is reversible process, and 2C1, this is irreversible process, so that is why 1A2C1, the cycle, that is irreversible cycle. Okay, this is considered, this is cycle 2. Okay, so here if you apply the cycle for cycle 1, here this is cycle 1, so from Clausius inequality you can say that in cyclic integral for reversible process del q by t, that is equal to 0. So in cycle 1, that is process 1 and process 2 is there. For cycle 1 there is a process process A and process B is there, and both process are reversible process. So here if you apply this formula, so here del q by t for process A plus del q by t for process B, that is equal to 0. So consider this is equation number 1. Okay, now for cycle 2, so for irreversible process you know that cyclic integral, for irreversible process you know that cyclic integral of del q by t less than 0. For this is for irreversible process. Okay, so for irreversible process this is cyclic integral of del q by t less than 0. From here in cycle 2 there is a process A is there is a process C is there. Okay, so this is cycle 2, this is process A is there and process C is there in cycle 2. So process A is reversible cycle and process C is irreversible cycle. So here, from here you can see that del Q by T for 1A2 plus del Q by T for 2C1, this is less than 0 from Clausius inequality. Okay, so this is cycle, this is equation 2. Okay, now so when you equation 2 minus equation 1, then you get equation 2 minus equation 1, you can get here del Q by T for process C minus del Q by T for process B, this is less than 0 from equation number 2 and 1. Okay, so from here you can get del Q by T for process C less than del Q by T for process B. Okay, so we know that this process C is a reversible process, so that is why del Q by T for reversible process less than del Q by T, and B process is reversible process, so del Q by T reversible. Okay, so from here you can say that del Q by T for irreversible process is equal to ds. Okay, so for irreversible process, so del Q by T less than ds. Okay, ds is equal to del Q by T for reversible process. So this equation is also very important. Okay, for a process, so del Q by T for irreversible process less than ds. So this is very important. Okay, so for process you can say that del Q by T less than equal to ds, for process. If it is a reversible process, you can say that del Q by T that is equal to ds, and if it is a irreversible process, then you can say that del Q by T less than ds. So these are very important. Okay, so here suppose there is an example is there, in this example, this is the example is there. In this example there is a one axis and there is another axis, and there is two state, is the state 1 and state 2, and one state is a reversible process and another process is a irreversible process. Okay, so this is going from this way, okay, this direction. Okay, so here this B process is the irreversible process. B process is the irreversible process and A process is the reversible process. So ds that is equal to h2 minus h1, and for dq by t for reversible process A, that is equal to, if there is a 10, that is equal to h2 minus h1, and for irreversible process del q by t for irreversible process that is equal to B, consider this is 8, then h2 minus h1 that is equal to 10. Okay, so so something is less, so here there is a 10, consider this is 10, entropy change that is 10, but here this is 8, because for irreversible process we know that this is the case here, del q by t for irreversible process that is less than ds. Okay, so that is why there is a 8 is there, that is less than 10. Okay, so for irreversible process the entropy is less than reversible process. Okay, now so here entropy is a property, we see that it means only depends upon two end point, imply that entropy change is same for reversible and irreversible process. Okay, irreversible both. Okay, so if you find entropy change for an irreversible process, then it is better to replace irreversible process by a reversible process. Okay, so this is the case. Now there is another example is there. So consider so this is system A. In this system there is insulated, there outside there is insulated, and this is system A, and this is the boundary here. This is the system boundary. Here this is the boundary, and in this boundary there is a coil is there. There is a coil is there, and this is system A. This is system A, and there is another system which is inside the system A, that is B system, and there is no there is a, this is the boundary is there, and this is not insulated. Okay, so for for A system A, energy transfer is there because so here energy is transferred through the boundary. Okay, so the energy is crossing through the boundary, so energy is transfer is there, work is also transfer is there, because work can transfer through this boundary also, but heat cannot be transferred because this wall is insulated. So that is why for system A the heat cannot be transferred, but as this there is heat is not transferred, the entropy will be, there is entropy that is equal to 0. Okay, but for system B the energy is also transferred, because in this system the energy may transfer through the boundary, because this is not an insulated boundary. Okay, but here work is not transferred, because we see that for system boundary, system A boundary, we see that the boundary so here the work is transferred, but in that boundary the work is not transferred is there, only heat can transfer, work cannot be transferred. So that is why, so here heat is all transferred, but what work is not transferred. As heat is transferred, there is entropy change is there. Okay, so from here you can say that this is the note point, energy is the form of in the form of kinetic energy and potential energy, and work are the high grade energy, and entropy associated with high grade forms of energy 0. Okay, entropy associated with uh, entropy associated with high grade form of energy, that is equal to 0. So basically energy in the form of kinetic energy and work, kinetic energy, potential energy and work are the high grade. So we know that high grade form of energy means work, that is kinetic energy, that means potential energy, or work is the high grade form of energy, and what is the low grade form of energy, that is heat. Okay, so entropy associated with high grade form of energy, that is equal to 0. Okay, so if there is any high grade form of energy, then the entropy associated with high grade form of energy, that is basically 0. So this is all about the basic concept of entropy. This is my handwritten notes, you can download it from the description. There is a Telegram group, you can join that Telegram group. Like, share, subscribe my YouTube channel. Okay, thank you.